All right, so we're going to look at some of your sample problems from section 6.2 where we're using the formulas. Starting with number 1, we have the perimeter of a rectangle formula. So you don't have to know that necessarily to do this section, but you might enjoy knowing a little more about it and how we're going to use it later. But it says the perimeter, which is the distance around a figure, is 2 of its lengths plus 2 of its widths. So 2 of these and 2 of these. So that's the formula. So if they give us L is 23, we input that for L, and W is 31, input that for W. It'll look like this. So 2 times 23 plus 2 times 31. Let's see, that's 46 and 62, or you can just totally type that on your calculator, but you should get 108 for that. Now notice we didn't really have to use any of our algebra tricks or equation solving to do that because all parts were known on the right side or one side. There was no variables mixed in this side, so I could just type it on my calculator on that first example. That's not always so on all these, as we'll see. On number 2, we have Z equals X minus U divided by sigma. And we're going to use this later in our statistics chapter. And this time it tells me what Z is, tells me what X is, and tells me what sigma is. Leaves out U. So it'll look like this, and I will have to do some equation solving. I know the Z value is 1.49. I know the X value. I don't know U, and I know sigma is 4. So the first thing I have to do is get rid of this divided by 4 by multiplying by 4. So when I multiply by 4, the divide by 4 cancels. Then that's why I have times 4 on this side as well to keep the balance. So 4 times 1.49 is 5.96. I bring down this numerator, 37.7 minus U. Then I'd bring the terms together to get the variables on one side, numbers on the other side. So 37.7 brought across the line is negative 37.7. Subtracting gives me negative 31.74 equals, and then this side still has a negative on it, negative U or mu. And I do need to divide off that negative sign to complete the process. I need to get a positive 1 to be done solving. So dividing each side by negative 1, this comes out to be positive 31.74 for our solution. Okay, number 3, this is the volume of a cylinder formula. Actually, you might notice pi r squared is how we find the area of a circle. You might remember knowing that, using that at some point, and then you times it by the height of the circle, the height of the can or cylinder, and you've got the volume, how much will fit in that. So the formula is given, and then they tell us the V value, the volume. They tell us to use 3.14 for pi, so be sure to use that and not your pi button. And then R is, where's R? R is 10. So we don't know H, right? They leave H out. So we do have to equation solve. So I input all these values into the formula. It looks like this. V 5966 equals the pi, the radius squared, times H unknown. So I'll go ahead and do what I can here on the right side. Multiply that. 10 squared times 3.14 on your calculator is 314. Equals the other side. And then we still have this times H here. We're trying to solve for H, so we divide. That's always our last step, you know, divide by what's on the variable. So dividing by 314 on each side gives you a height of 19 actually. Okay, number 4, 5, and 6, we move to the Fahrenheit formula. You'll notice on number 4 and number 5, they give us the Fahrenheit equation, and then on number 6, they give us the Celsius equation. I want you to notice, though, they're actually the same formulas. They've just been rearranged in terms of C or F, but they're equivalent formulas. So we can use them to go back and forth between Celsius and Fahrenheit. So the first problem, number 4, asks us to fill in 15 degrees Celsius. So we input that for the C variable in the formula, and it's 9/5 times whatever C is plus 32 converts Celsius to Fahrenheit. So inputting that, use your calculator. 9 divided by 5 is about 1.8 as a decimal, so you might prefer the decimal version. But 1.8 times 15 plus 32, boom. So you're able to plug that directly in your calculator. No equation solving needed. Same thing on number 5. They tell us the Celsius value to input for C, so we could do this all day long. They could say Celsius 26, 27, 28, and we could do repeated calculations here. So just each time take whatever they tell us for Celsius, plug it in for C. It's multiply between those. So 9/5 times 26, then plus 32 converts it to our Fahrenheit. Okay, number 6, we go the other way. Number 6 asks us to take something in Fahrenheit, convert it to Celsius. Now note, we could have done that up here. We could have put 59 here, and then I would have had to equation solve. I would have brought the 32 across and yada yada. But they've done that for us in the formula and rearranged it for us. So we plug the 59 in for the F value. So converting F to 59 will look like this. 5/9 times 59 minus 32. Use your calculator to do that. You should come out with a 15 degree Celsius. All right, hope that helps.